Okay, this is going to be a proof of the product rule. The product rule is a tool we use to take the derivative of a function that is made up of a product of two other functions. So we start by defining this function that we're talking about, y, as u times v, right? Where u and v are just functions of x. They're just sort of normal functions. And we're going to start with a picture of the graph of y, okay, with respect to x. Okay, and I'm just going to draw a generic function here. It could really be anything. And the definition of derivative comes from really the slope formula. You have x1 and x2, but we're going to say this is x plus delta x. Okay, and that gives us two corresponding points on the y-axis, y, and then what we're going to do is have y plus delta y right there. Okay, this is delta y, that little gap there, and this would be delta x. All right, and so that gives us the definition of derivative. It's y2 minus y1 over x2 minus x1, and we take the limit as x2 approaches x1. But we're going to write it like this. We're going to have, instead of y2 minus y1 or f of x plus h minus f of x, we're going to have y plus delta y minus y over delta x. So that's just the definition of derivative. For our next step, in order to understand our next step, we're going to look at the at graphs of the u and v functions. So let's say this is u, okay, and it's going to look really, I'm just going to draw again a generic function. It's going to look exactly like our graph that gave us the definition of derivative for y, but we're just going to use the different letters here. So we plug in an x and you get a u value. If you plug in x plus delta x, you get u plus delta u, right? Okay, and u in this whole proof is going to be represented by the color red, and v is going to be represented by the color blue. So here's our v graph. Okay, I love it when that happens. Okay, here's the x-axis, and again, this looks just the same, but so that we're on the same page here. This gives us a v value, and this gives a v plus delta v. All right. So when you plug in a value for x into u and v, these are independent functions. So you plug x into each of them, right? When you plug x in, you get a u, and when you plug x into v, then you get a v, right? And to get y, you multiply u times v, right? When you plug in x plus delta x, you get u plus delta u, and then you plug in x plus delta x to v, and you get v plus delta v, right? And that's this. And if we multiply u plus delta u times v plus delta v, then what we get is the same thing we would get if we plugged in x plus delta x to y, and we get y plus delta y. And therefore, y plus delta y is equal to u plus delta u times v plus delta v. Okay, so that's what you see up here in this first step. You see the u plus delta u times the v plus v plus delta v minus u times v, because that's what y is equal to, right? So y becomes u times v. The y plus delta y becomes u plus delta u times v plus delta v. And we go from there. The rest of this is just simple, algebraic or any sort of mathematical alterations and modifications, moving stuff around. Next step, take the product of these two quantities, the u plus delta u and v plus delta v, and we FOIL it out. And we get this right here, right, when we FOIL it. It looks like that. U times V, and then delta U times V, and then U times delta V, and delta U times delta V. Okay, and then of course the U times V's cancel. Okay, and that's the only difference between these two steps, right? Is the U times V's are gone. What we do next is distribute the delta x into each of these three terms, right? And so we get these three fractions, right? With delta x dividing into each one of them. And then from that step to this next step, it's a simple just rearrangement. Since these are just products, we take the v and kind of move it down in front, right? So that it's in front of that fraction of delta u over delta x. And same thing with the u and the delta u over here. And you could just as easily have done delta v on that third fraction. Either way, it doesn't matter, but we're going to do it this way. Then what you see here, the limit was turned green. Just leave that. The limit was turned green. And what we do from this step to the next one is we sort of distribute the limit. We use the limit theorems or limit properties, and we use the limit of a sum, right, to take the derivative, to take the limit of each of these three parts. And here we use the limit of a product. Okay, so two limit properties kind of at once. We took the limit of each of these three fractions, and then again on the third one we split it further with the limit of a product. You'll notice the v and the u are not inside the limits, and that's because as delta x changes, u and v don't change. So you can look down here at one of these graphs and say there's delta x, and no matter what delta x does, it just moves this line right here. It doesn't move u, right? Let's get rid of that. Okay. No matter what delta x does, u just stays the same. And same thing, as delta x changes, v doesn't change. It just stays there. It's this line that moves as delta x changes. So that's why we can pull the u and the v out of those limits and not have to and get them out of there. What that does for us then is now we have the limit as delta x approaches 0. The limit as delta x approaches 0 of delta u over delta x, which of course is equal to du dx. Or in other words, the derivative of u with respect to x. And in the same way, we have the limit as delta x approaches 0 of delta v over delta x, which is of course dv dx, or the derivative of v with respect to x. Okay, so how do we deal with all this stuff over here? We have this right here as the limit as delta x approaches 0 of delta u. Well, this is delta u right here. As delta x approaches 0, delta u is also going to approach 0. So that's why you see this red 0 right here. Right? Now this is the derivative as it was before. These two things are the same here. So we get dv dx right there. But it doesn't matter because 0 times dv dx is just 0. So that goes away, which is great because we didn't want that around anyway. Our next step is just a rearrangement to put v in front, or sorry, v in back, u prime in front, so that we can write it the way that we familiarly see it. U prime v plus v prime u. And we're done.